In this lecture, we will see how a logic function can be implemented using multiplexer. So the first question for that is use a multiplexer to implement the logic function f is equal to a XOR b XOR c. So the first step of our design procedure is to write the truth table. So we have written the truth table here with the inputs a, b, c because the variables used here are a, b, c. So we wrote the variable names as a, b, c. So since there are three variables, you will be having 2 raised to 3, that is 8 input combinations. So starting from 0, 0, 0 to 1, 1, 1. Now, what will be the result? That is, what will be your A XOR B XOR C for the input 0, 0, 0? That will be written on the right hand side as the output. Okay, so we know that if we want to perform the XOR operation of three variables, then the result will be 1 for odd number of ones. So the XOR among three variables, if you have odd number of ones, the output will be 1, and the number of ones is even, then the output will be 0. So the first case is input is 0, 0, 0. There is no 1 in that input, hence the output is 0. Next is 0, 0, 1, single 1, odd number of 1, hence the output is 1. Next case 0, 1, 0. Here also single 1, hence the output is 1. 0, 1, 1, even number of 1s, hence the output is 0. Next case 1, 0, 0, odd number of 1, hence the output is 1. 1, 0, 1, even number of 1s, hence the output is 0. 1, 1, 0, even number of 1s, hence the output is 0. And the last case 1, 1, 1, odd number of 1s, hence the output is 1. Now the next step is how this truth table can be implemented onto the mux. So in the question we have seen that f is equal to a XOR b XOR c. So these three variables, that is the three inputs, when implemented on mux becomes the three select lines. That is why it is written as S2, S1 and S0 just above A, B, C. So the inputs, that is a number of variables in the question will become your number of select lines for the multiplexer. Hence here the number of variables is 3, they are A, B, C. Now those A, B, C becomes your select lines S2, S1 and S0. Okay, so the mux with the 3 select lines. So what type of mux will be that? How many inputs will be there for that mux? We know that if the number of select lines is 3, then the input will be 2 raised to 3, that is 8. So 8 to 1 mux. Okay, so this function can be implemented using 8 to 1 mux. So this is the 8 to 1 mux having 8 input lines starting from D0 to D7. Okay, and the select lines S0, S1 and S2 are your variables, that is A, B and C respectively. Okay, so A becomes your MSB, that is S2, B becomes your S1 and C becomes your S0. Okay, so these are your select lines, and since there are 3 select lines, 8 input are there. So this is an 8 to 1 mux. Now what is the inputs which we have to provide on these input lines? That is your output obtained on the truth table. So the first 0 will be acting as the input to D0. So D0 will be provided with 0 and D1 will be provided with 1, D2 will be provided with 1, D3 will be provided with 0. Okay, D4 it is 1, D5 it is 0, D6 it is 0 and D7 as 1. That is why here you have provided as 1 and 0, and this 1 is connected to the corresponding inputs. Okay, so when this select lines, when we provide this address of these pins, the corresponding pin will be selected and that is routed towards the output function. Okay, so let's check what happens when we provide the input as 5. Okay, when we provide the ABC function as 5, that is A is 1, B is 0 and C is 0. Okay, that is you are providing the select lines as you are providing the input 1, 0, 1 is provided as the input. What happens when you provide the mux input as 1, 0, 1? That is what is the output of the function if my A, B, C are 1, 0 and 1? That is what we have to implement, isn't it? 1, 0 and 1. So what happens? We know that when my A, B, C 1, 0, 1 is provided, then the function f will be 0 because it has got even number of ones. Yes, 1, 0, 1, then it will be 0. Let's check how the mux works. What you will get for f when we provide the select lines A, B, C as 1, 0 and 1. What happens? 1 0 1. When the select lines is provided as 1 0 1, the mux will select the D5 input. D5 input will be routed towards your output. Okay, what is D5 input? D5 is input provided with a 0. So what we will get on the output is 0. What we have to obtain on the output is 0. So that is right. Now suppose we are providing the input that is 1 1 1. That is, if A B C are 1 1 1, if your ABC are 1 1 1, then the output has to be 1 as per the equation. As per the equation, your output F has to be 1. So when you are providing these select lines as 1 1 and 1, the mux will select your D7 pin. D7 pin is provided with the input 1. So what will be routed towards your output? 1 will be routed towards your output. The function will get the output as 1. So this is how you are going to implement your mux, that is with the logic function. That satisfies this logic function. Okay, the number of variables becomes your number of select lines, and just implement the output as the input to the mux. Okay, so these three variables are there, so three select lines will be there. So 2 raised to 3, 8 is to 1 mux is going to implement this function. Hope that is clear for you. Now moving to the next topic. Sometimes the question may ask like this. That is, you have to implement a particular question with a reduced mux. That is, just see this example.